Welcome back. In this video, we are going to solve problem 5.58 that is taken from chapter number 5, Analysis and Design of Beam for Bending, and book name is Mechanics of Material by Beer Johnston, 6th edition. So statement is draw the shear and bending moment diagram for the beam and loading shown and determine the maximum normal stress due to bending. So you can see this is a simply supported beam AB having pin support at point A and a roller support at point B. And there is a uniformly distributed load from C to D having 80 kilonewton per meter. At point A we have counterclockwise movement of 60 kilonewton, and at point B we have 12 kilonewton into meter clockwise movement. And this is wide flange beam which is W250 by 80. So you have to draw the shear and moment diagram. So let's start with the solution. So first step, if you remove this pin support at point A, so you will be having a vertical reaction force which is represented as A, and if you remove this roller support at point B, you will have a vertical reaction force B. So first we will find this A and B by using equation of equilibrium. So first equation of equilibrium is that sum of all moment about point B is equal to 0 and taking the counterclockwise moment as positive. So about point B, the first moment is 12 kilonewton which is clockwise, so I will take it as negative, so minus 12. The second moment is due to this distributed load, and this distributed load when converted into point load, so it will be equal to 80 multiplied by 1.6, and it will act at a distance of half of 1.6, which will be equal to 1.6 divided by 2 is 0.8, so 0.8 meter. So this load 80 into 1.6 into perpendicular distance is now 2 meter, and this is producing counterclockwise movement, so it will be positive. So I will write plus 80 into 1.6 multiplied by 2 meter, and the third load which is producing movement is A, and perpendicular distance is, this is 1.6, 1.2, 1.2 is 2.4, 3 and 4, it will be 4. So 4 into perpendicular distance is 4 meter, and this is clockwise, so it will be negative. So I will write it minus A multiplied by 4, and the last moment is 60 kilonewton into meter which is counterclockwise, so I will write plus 60, and their sum must be equal to 0. So minus 12 plus 80 multiplied by 1.6 multiplied by 2 is 256, minus 4 times A plus 60 is equal to 0. So I will take minus 12 plus 256 plus 60 will give you 304, and that will be 4A will be equal to 304, and from here A will be equal to 304 divided by answer divided by 4 will give you 76. So 76 kilonewton. Now you have this force. So what we will do is that we will calculate this B by using another equation of equilibrium, is that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So A, which is upward, so 76 minus this 80 multiplied by 1.6. So 80 multiplied by 1.6 will give you 128 kilonewton. So this is minus 128 plus this B is equal to 0. So from here you will get this 76 minus 128 will give you minus 49. Oh, sorry, 128, not minus 52. So B will be equal to plus 52 kilonewton. Okay, now we have these two reaction forces. So what we will do is that we will move toward shear force and bending moment diagram. So for that I have to draw the vertical lines from the end of this beam. Okay, and first we will draw the shear force. So for shear force I will need a horizontal line to show the length x in meter, and on y-axis you have shear force having unit kilonewton. Okay, so starting from A, I will write shear force. So starting from A, as you can see at point A we have A force vertical reaction which is 76. So we can write it as VA is equal to 76 kilonewton. Now from region A to C, you can see there is no load between these two, so it will remain same. So V shear force will be equal to 76 kilonewton. Okay, at region of D, okay, from C to D and at point D, this shear force VD will be equal to, it will be equal to here at this point, the shear force will be equal to VA plus this one. You can see this 80 multiplied by 1.6 will give you shear force at this point. Clear? So I can write it, it will be equal to 76 minus 80 multiplied by 1.6. Okay, and that will give you 76 minus 128. So it will give you minus 52 kilonewton. Okay, so VD is equal to minus 52 kilonewton. Okay, from D to B, and you can see from D to B there is no load, so shear force at point from D to B will be equal to minus 52 kilonewton. Now you have all these values, so let's move and draw the shear force diagram. So for that I will take the scale. So let we take one division is equal to 25 kilonewton, so it is 50 and this will be 75, and same is the case minus 25 and minus 50. Okay, first at point A we have shear force of 76 kilonewton, so it will be somewhere here. So let this is 76. Now moving from A to C, this is your point C. Here, so from A to C you can see the shear force remains same, so it will be like, sorry, it will be horizontal. Okay, now what is the shear force at point D? So it is minus 52. So D point is this point. I can write D is minus 52, so it will be like this. Okay, minus 52 kilonewton. Now you can see that the distributed load is a horizontal line with 0 degree, so shear force will be 1 degree higher, and it will be a straight line by joining these 2 points, and slope will be decreasing because this force load is downward. Now from D to B there is same shear force which is minus 52 kilonewton, and at the last you can see you have B which is plus 52, and that will bring it to the 0. So this will be your shear force diagram. Again you can see that at this point you can see the shear force is 0, and at this point you will see in a while that bending moment will be maximum. So what we will do is that we will find the location of this point from this end. For that I will take let this distance, and the distance, this distance is taken as x. So this is x. So distance from this point till this point D, this will be equal to how much? So we will see that the total distance is 1.6. This is x. So this will be equal to 1.6 minus x. Now what we will do is that you can see you have two similar triangles. One is this one and another one is this one. So the ratio of their side must be equal to 0. So I will take x divided by 76. That will be equal to 52 divided by 1.6 minus x. So let me write it. X divided by 76 is equal to 1.6 minus x divided by 52. So from here 52x is equal to 1.6 times 76 minus 76x. So 52x plus 76x is equal to 121.6. 1.6 multiplied by 76 is 121.6, and 52 plus 76 is 128. So this will be 128x is equal to 121.6. So x will be equal to 121.6 divided by 128. This is 128. So you will get x will be equal to 121.6 divided by 128. So it will be 0.95. So x is 0.95. And that will be from this till this. So 1.2 plus 0.9 will give you 2.1. So this is 2 at a distance of 2.1 from point A. The shear force will be 0 at that point. 0.95. This is 95 meter. Now we will move toward the bending moment diagram. And for bending moment diagram, we know that for bending moment, let me write it. Bending moment can be obtained by taking the area under the shear force diagram. So area of shear diagram. Okay. So first area you can see from A to C. So this is your point A, and this is your point C. So this is the first area under the shear force diagram, and this is rectangle here. So its area will be 76 multiplied by this length. So this length is 1.2 meter. So I can write it from A to C. The shear force will be, the area under the shear force, which is represented as integral of B into dx, that will be equal to 76 multiplied by 1.2, and that will give you 91.2 kilonewton. You can calculate it as well into meter. Now from C to A, first we will calculate this area from C to E, and let this point is E where shear force is equal to 0. So from C to E, this is the area under the shear force diagram, and you can see this is a triangle. So its area will be 1/2 this height, which is 76 multiplied by this x, which is equal to 0.92. This is the value 95. This is the value of x. So integral of v into dx will give you bending moment, and that will be equal to 1 over 276 multiplied by 0.95, and that will give you the value equal to 36.1 kilonewton into meter. Now from E to D, so this area you can see E to D. So this is the E to D area under the shear force is this one, and again this is triangle, so its area will be 1 over 2 multiplied by 52 minus 52 multiplied by this length, and this length will be 1.6 minus 0.92. Okay, so I will write integral of v into dx will be equal to 1 over 2 minus 52 multiplied by, if you take 1.6 minus 0.95, that is 0.65. I will write 0.65. So multiplying this, we will get minus 16.9 kilonewton into meter. And the last area is from D to B. At the end we have point B. So D to B is this portion. So area under the shear force diagram is rectangle. So you can see this will be minus 52 multiplied by its length is 1.2. So I will write it from D to B. Area under the shear force diagram is minus 52 multiplied by 1.2, and that is equal to minus 62.4 kilonewton. Now what we will do is that we will draw the bending moment diagram. So for bending moment diagram, again if I extend these lines, so I will draw a horizontal line to show the length in meter, x in meter. On y-axis you have moment and unit kilonewton into meter. So you can see at point A we have been given bending moment MA, which is 60 kilonewton counterclockwise. So while drawing, remember that while drawing counterclockwise movement on bending moment diagram, it will cause it to go downward. So we will take each division as, for example, 30. So this is minus 20, minus 40, and minus 60. Each division is 20. So your first point will be this one. So this is bending moment at point A. Now what will be, I will write it MA is equal to minus 60 kilonewton into meter. Now this is your point C, this is your point C, this is your point E, and this is your point D. Okay, so what we will do is that moment at point C, MC will be equal to MA plus area under the shear force diagram from A to C. So I will write minus 60 plus 91.2 will give you moment at point C, which is 31.2 kilonewton into meter. So we will locate it. This is minus 20 plus 20. This is plus 40. This is plus 60. So 30 will be somewhere. 32 will be somewhere. 31.2 will be somewhere here. 31.2. Okay. And you can see that the shear force is a horizontal line with 0 degree curve. So bending moment will be 1 degree higher, and it will be a straight line, and slope will be increasing. Okay. So this was moment at point C. Now moment at point E is equal to moment at point C, which is 31.2 plus area under the shear force diagram for C to E, which is 36.1, and both of this will give you 67.3 kilonewton into meter. So at point E this will be 67.3. So let's say 67.3 will be somewhere here. I will take it approximately 67.3 kilonewton, and you can see that shear force is a 1 degree line and slope is decreasing. So bending moment will be a 2nd degree curve. It will be like this and in clockwise direction. Okay, now bending moment at point D will be equal to bending moment at point E. Why at point E? Because you can see at point E this is the bending moment. So at point D will be equal to 67. I will cut it instead of that. I will write 67.3 plus area under the shear force diagram from E to D is minus 16.9 kilonewton, and that will give you 50.4 kilonewton into meter. So at point D it is 50.4. So let's say 50.4 will be somewhere here at this point, 50.4. Again you can see that shear force is a single degree, 1 degree line, straight line, and slope is decreasing. So bending moment will be 1 degree higher, and it will be a like curve in this form. Okay, and the last area or moment at point B is equal to moment at point D, which is 50.4, and area under the shear force diagram from D to B, which is minus 62.4 kilonewton. That will give you minus 12 kilonewton into meter. So it will bring it to minus 12. So minus 12 will be somewhere here at this point. You can see this minus 12 will be somewhere here. This is minus 12 kilonewton into meter. And shear force is a horizontal line with 0 degree, and this area is negative. So bending moment will be 1 degree higher, and it will be a straight line, and slope will be decreasing. But at the end you can see you have a bending moment of 12 kilonewton, movement of 12 kilonewton into meter, that is clockwise. So while drawing a clockwise movement on bending moment diagram, it will go upward. So minus 12 plus 12 will bring it to 0. So this will be your bending moment diagram. Now in second part, we have been asked determine the maximum normal stress due to bending. So again, we can say that maximum bending stress is equal to maximum bending moment absolute value divided by section modulus. So what is the maximum bending moment? So maximum bending moment from the bending moment diagram, you can see this is 67.3 kilonewton into meter. Okay, there is a meter sign as well. And that will be equal to 67.3 into 10 to the power 3 Newton into meter. What about section modulus? So Sx can be obtained from the appendix of this book. I will move toward the appendix. So you can see at appendix C, property of rolled steel. So you have to move SI unit W. What was given? W 250 multiplied by 80. So W 250 multiplied by 80 will be somewhere downward. Okay, now you can see on this page. First, you have to be very careful. You have to see, sorry, W 250 by 80. So W 250 is this and 80 is this. So in that you will go to 983. So 983, but you have to go upward. And this is 10 to the power 3 cubic millimeter. So I will write it 983 into 10 to the power 3 cubic millimeter. Let me check it again. 10 to the power 3. Okay, yes. So in meter, it will be equal to 983 into 10 to the power 3, and it will be 10 to the power minus 12 cubic meter. And that will be, so the 10 to 10, 339. This is not 12, this is minus 9. Okay. So 983 into 10 to the power minus 6 cubic meter will be Sx. Now you have both the value, just plug it. 67.3 into 10 to the power 3 Newton into meter divided by 983 into 10 to the power minus 6 cubic meter will give you maximum bending stress. And this maximum bending stress will be equal to 68.5 into 10 to the power 6 Pascal, because Newton per meter square is Pascal. And from that, if you want to get it in megapascal, so it will be 68.5 megapascal. And which is the answer of our second part. So this was all about this problem 5.58. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Also, give me your valuable feedback by commenting on my videos so that I may know how my videos are going on. Thank you. Welcome back. In this video, we are going to solve problem 5.85 that is taken from chapter number 5, Analysis and Design of Beam for Bending, and book name is Mechanics of Material by Beer Johnston, 6th edition. So statement is determine the largest permissible value of P for the beam and loading shown, knowing that allowable normal stress is 6 ksi in tension and minus 18 ksi in compression. So this is the beam, and that is overhanging beam with a point load of P at point B and at point D. The cross section of the beam is shown. So you have to determine the largest permissible value of this P. So let's start with the solution. So first of all, what we will do is that if you remove this roller support at point A, so you will be having a reaction force which is Ra, and similarly if you remove this pin support at point C, so you will be having a reaction force which will be equal to RC. So we'll find this RA and RC by using equation of equilibrium. So first equation of equilibrium is that sum of all moment about point C is equal to 0. So about point C, this force is passing through RC, so it is not producing moment. So starting from A, the first force that is producing moment is RA, and perpendicular distance is 30, and this is producing clockwise moment, so I will take it negative. So minus RA into 30. The second moment that is produced due to this P load and perpendicular distance from this point load to C is 20. So it is producing counterclockwise movement, so it will be positive. So I can write it as plus P into 20. And the last moment that is produced by this force and perpendicular distance is 6. And this is producing clockwise movement, so it will be negative. So we can write it as minus P multiplied by 6 is equal to 0. So minus 30 RA plus 20P minus 6P is equal to 0, and from here minus 30 RA plus 14P is equal to 0. So RA, 30 RA is equal to 14 times P, and RA will be equal to 14 divided by 30 P. And from here, what we will get is that RA will be equal to 0.46667 P. Since it is positive, so this force will be upward. Now we'll find this RC by using equation of equilibrium, and what will be the equation of equilibrium? That sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So RA, which is upward, and that is 0.46667 times P minus this P and this P. So minus P plus this RC, which is upward, is equal to 0. So we can write it as this. When you calculate, you will get this RC will be equal to 1.5333 times P. This is also positive, so our assumed directions are correct. Now, what we will do is that we will draw the shear force and bending moment diagram. Why? Because we know that bending stress is equal to moment into C divided by I. So for that, we will need the moment. And you can see along the length of beam, the moments vary. So let's start drawing this bending moment diagram. So I'm drawing the two vertical lines from the end of the beam. On x-axis, we can take the length of beam x is in inch, while on y-axis you have shear force. Okay, now what we will do is that, again, you can see that RA is how much? 0.446. So let this is 0.4667 times P. So starting from this, moving from A to B, there is no load. So from A till B, this will remain same. Now at this point, we have minus P. So 0.466 minus P will bring it to minus 0.533. So let's say 0.533 is this point. So it will change it to this point. I will write it minus 0.533 P. Now from B to C, there is no load. So it will remain same till this point. And at point C, you can see you have RC, which is equal to 1.533. So minus 0.533 plus 1.533 will bring it to 1. So let's say 1 is this point. So this shear force will change from this to 1. Okay. Now moving from C to D, there is no load, so it will remain horizontal. But at the end, this will be P, because there is a P. Okay. Now at the end, you can see minus P which will bring it to 0. Okay. So this will be your shear force diagram. Now from this shear force diagram, what we will do is that we will draw the bending moment diagram. Again, x will be in inch, and on y-axis you will be having moment. Now we know that area under the shear force diagram will give you moment. So this will be the first area. I will write it as A1, and this A1 will be equal to 0.4667 multiplied by this length, which is 10. So I will get it 4.667. So at point A, you have moment is equal to 0. Now at length of 10 inch, what is the moment? That is 4.667 times P. So let's say this is 4.667 times P. 4.667 times P. And you can see that shear force is a horizontal line with 0 degree. So bending moment will be 1 degree higher and its slope will be increasing. So we will get this straight line. Let me draw it straight line by combining these 2 points. Okay. Now this is the second area, A2, and this second area is equal to minus 0.553 multiplied by 20. And that will give you what? That will give you the value of minus 10.6667 times P. Okay. Now what will be the bending moment at this point? So 4.667 P minus this A2 value, minus 10.667 will give you minus 6. Okay. So this will be the minus 6 will be the, let's say this point is minus 6. So minus 6 P. So bending moment will be this. And you can see that shear force is a horizontal line with 0 degree and its value is negative. So bending moment will be 1 degree higher and its slope will be decreasing, and it will be a straight line. I will draw it again, a straight line. Okay. Now the last area is this area, and this area is A3, and this is height is P, and this is 6 inch. So it will be equal to 6P. So minus 6P plus 6P will bring it to 0, and bending moment will be 1 degree line and slope will be increasing because A3 is positive. So this is what we get the bending moment diagram. Okay. Now you can see from this formula, we will get the bending moment from the bending moment diagram. What about I? I is the moment of inertia, and cross section is shown over here. So by using parallel axis theorem, we will find the moment of inertia for this T shape. So formula is that I is equal to sum of 1 over 12 BH cube plus AD square. Okay. Now we do not know, as this section you can see on y-axis, if I divide it into half, it is symmetrical, but about x-axis is not symmetrical. So we will find the centroid of this section, and formula for centroid of this section can be obtained by using this formula, that y bar is equal to sum of y dash into a divided by sum of area. So let's say this is 1 and this is, let's say this is 1 and this is 2. Clear? So we have divided this T section into 2. So according to that, formula will be equal to y1 bar into a1 plus y2 bar into a2 divided by a1 plus a2. Now what is a1? And a1 is the area of first section above horizontal section, and a2 is the area of second section. Okay, for that, for finding the centroid y dash, this one, we will take this horizontal line as a reference line, and what we will do is that we can see that area A1 is equal to this area. This area is equal to 4 inch multiplied by 0.5. So area is 4 multiplied by 0.5. And what is y1 bar? So y1 bar is distance from this reference line till the mid of this section. So this will be equal to how much? You can see this is 2 and half of 0.5 is 0.25. So it will be 2.25. I will write it y1 bar. So 2.25. Now what is A2? So A2 is the area of this vertical portion, and you can see this is 0.5 multiplied by 2. So 0.5 multiplied by 2. And what is y2 dash? So y2 dash is distance from neutral axis till the mid of this section, the second one. So total height is 2. So it will be equal to, this will be equal to y2 bar, and that will be equal to 1 inch. Now you have all the values, just plug it in this formula. So we will get y dash is equal to y1, which is equal to 2.25 multiplied by area A1 4 multiplied by 0.5 plus y2 is 1 inch multiplied by 0.5 into 2 divided by sum of area, which is 4 multiplied by 0.5 plus 0.5 multiplied by 2. And when you solve this, you will get the centroid will be equal to 1.8333 inch. Now what does it mean? It means that your centroid is from this baseline, it is equal to, this is y dash bar. I will write it. This is y dash bar, and that is equal to 1.8333 inch. And the remaining top, this distance will be equal to 2.5 minus 1.833, and we will get 0.6667 inch. Now we will move toward finding the I, moment of inertia. So as we know that I is equal to sum of 1 over 12 BH cube plus AD square. So for section 1, I will write for section 1, I will be equal to 1 over 12 B1 H1 cube plus A1 D1 square plus, for section 2, it will be equal to 1 over 12 B2 H2 cube plus A2 D2 square. Okay. So I will write it, I is equal to 1 over 12. So for section 1, you can see that its breadth is 4 and height is 0.5. So I can write it as 4 multiplied by 0.5 cube plus area is 0.4 multiplied by 0.5, not 0.4, this will be 4 multiplied by 0.5. And what is D square? So D square is distance from neutral axis till the mid of first section. So this is the neutral axis. You can see this is the neutral axis and till the mid of this section. So you can see 0.666, clear? 0.666, sorry, not 0.6. It will be, this total distance is 2.5. So if you subtract this y bar from 1.883 from 2.5, so you will get a distance from neutral axis till the mid. Am I right? Not. Okay. You can see from this till the mid of first section is 2.25. So 2.25 minus this distance 1.833 will give you distance from neutral axis till the mid of this section. So I will write 2.25 minus 1.8833, and we will get square. This will be the moment of inertia of first section plus 1 over 12. Now for the second section, you can see breadth is 0.5 and height is 2. So 0.5 multiplied by 2 cube plus this area, which is 0.5 multiplied by 2. And now what is D square? So D square, D2 square. So D2 is distance from neutral axis till the mid of this section. So 1.883 minus 1 will give you this distance. This distance is D2. Okay, this distance will be d2. So I can write it as 1.833 minus 1 square. Okay. Now when you calculate this, you will get this, the value of I, and I will be equal to 1.41667 inch power 4. Now you have all the values, so we will move to find the value of P. As we have been given that allowable stress for tension and allowable stress for compression both are given. One was plus 6 ksi and another one was minus 18 ksi. And from this shear force and moment diagram, you can see moment at this point is plus 4.6 times P. And due to this loading, you can see it will bend like this, so moment will be over here. So this top portion will be in compression while this bottom portion will be in tension. So what we will do is that I will write it at section B. If I draw the beam like that, so this is your beam. The moment at net moment at point B is equal to how much? 4.667 times P, and let this is your point, small point B, and this is your small point A. I will show it over here. This will be section B, and this is your small point B, and this will be small point A. You can see due to the moment, this upper portion will be in compression and lower portion will be in tension. So what we will do is that for compression at B, small point B, we have been given allowable compression for point B. That will be equal to moment at point B into CB divided by I. So moment about this, you can see at point B, this will correspond to point B. Clear? So this is moment at point B, 4.6667. And what is C? So C is distance from neutral axis, CB, distance from neutral axis till top, and you can see this is the distance, 0.667 B, 0.6667, that will be, and I we have calculated is 1.41667 inch 4. I forget to put the P over here as well, and allowable stress is 18, that is in compression. Clear? So what we will do is that you can get 18 multiplied by 1.41667 divided by 4.6667 multiplied by 0.6667 will be equal to P. And when you calculate this P, you will get 8.20 kips. Now for the lower portion in the tension, for tension at point A, this is your point A, we have been given allowable tension at point A will be equal to moment at point B into CA divided by I. So moment is same, 4.667 times P multiplied by CA is distance from neutral axis till the bottom layer, and that is 1.833. So I can write 1.833 divided by I is 1.41667, and allowable stress is 6 ksi. So from here, now you can solve it and you will get P will be equal to 0.994 kips. Okay. This is for the section B only. Now what we will do, you can see we have one moment is this. So along the length, the bending moment change. So another one is minus 6P. So what we will do is that we will take section C, and we will repeat the same procedure. So for section C, I will draw the beam like this. Now you can see the moment is negative and you can see the load is upward. So this moment will bend like this. So you can see that this load is downward. So due to this load and this load, the moment will be negative and the moment will be like clockwise. So that is minus 6P. So I will write it as minus moment is equal to 6P. Okay. So again, this is your point B and this is your point A. So what we will do is that for point B, now the point B due to this moment will be in tension. So allowable tension for point B will be equal to MC into CB divided by I. So put the value MC is 6P, CB is for this distance is 0.667, 0.667 divided by I is 1.41667, and allowable stress is how much? Allowable is 6 ksi. So 6 is equal to 6P into 0.667 divided by 1.4167. So So from here you will get P will be equal to how much? This will be equal to 2.13 kips. Okay, I will change the color for point A. Point A. Again, allowable compression will be equal to MC into CA divided by I, and you have 6P is MC, CA was 1 point, CA will be, now you can see CA is again distance from neutral axis till the bottom is 1.88833 divided by I is 1.41667 and allowable stress is 18 kSI. So from here what we will get, P will be equal to 2.32 kips. Now you can check that we have 4P, 1P is this one, 1P is this one is this one, and this one. So these two P's are for section B, clear, where the moment is 4.677B. So allowable, for allowable compression and tension we have calculated P, and this one is for section C where you have P or this one. So what we will choose, what will be our answer? So our answer will be, you have to choose P is equal to 0.994 kips. This will be our answer. What is the reason? Because we have to choose the smallest, because if you choose this P over here, clear, so it will be safe for all the sections, or for all the section the tension and compression will be less than the allowable. If you choose the largest one, so definitely this beam will be fail for the allowable tension and compression stresses. And that was all about this problem 5.85. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching. Welcome back. In this video, we are going to solve problem 5.86 that is taken from chapter number 5, Analysis and Design of Beam for Bending, and book name is Mechanics of Material by Beer Johnston, 6th edition. So statement is determine the largest permissible value of P for the beam and loading shown, knowing that allowable normal stress is 6 kSI in tension and minus 18 kSI in compression. So you can see this is a simply supported beam having point load P at B and C, and the cross section of the beam is shown. This is inverted T, so you have to find the largest value of P that can be applied. So let's start with the solution. So first step is that if you remove this roller support at point A, so we'll have reaction force which is RA, and if you remove this pin support at point D, so you will be having a reaction force RD, and you can see these two loads are acting at a distance of 8 inch from either side. So due to symmetry, we can say that this RA and RD is equal to P. We will also calculate it. How you will calculate? So we will take the equation of equilibrium. So first equation of equilibrium is sum of all moment about point D is equal to 0, and taking the counterclockwise moment as positive. So about point D, the first moment is due to this RA, which and perpendicular distance is this one, which is 8 plus 8 plus 16, which is 32, and this is producing clockwise movement, so it will be negative. So I can write it over here that RA multiplied by 632, clear, that is minus, and the second moment is due to this P load, and now perpendicular distance is 24, and this is producing counterclockwise movement, so it will be positive. So I can write plus 24 times this P. The last load due to which is creating movement about point D is this P, and perpendicular distance is 8, and this is also counterclockwise movement, so it will be positive. So plus 8P is equal to 0. So minus 32R plus 32P is equal to 0. So from here 32 times P, 32P is equal to 32RA there, and from here what we will get is that RA will be equal to P. Now we can also find this RD by using equation of equilibrium, that is sum of all forces in y direction must be equal to 0, and upward force is taken as positive. So P, RA is P minus P plus minus P plus RD is equal to 0. So you can see that this P will cancel with this, and we will get RD will be also equal to P. Now we have RA and RD. So what we will do, we know that stress is equal to M into C divided by I. So for beam and the loading shown, we will find the moment, bending moment diagram. So for that, I will draw the vertical line from the end of this beam. First, we will draw the shear force diagram in order to find the bending moment diagram. Here, x will be in inch, and on y-axis we will have the shear force. Okay, so let one division is equal to P, so this will be equal to 2P, similarly minus P, and so on. At point A, we have RA, which is equal to P, so your first point will be this one. Now, from moving from point A to B, there is no other load, so it will remain same. P, and at point B you can see you have minus P, so P minus P will be equal to 0 at point B. This is point B. Now from B to C there is no other load, so it will remain horizontal till point C. Let this is point C, so it will remain same horizontal line till point C. And at point C you can see you have minus P load, so it will go down till this point, and from C to D there is no load, so it will remain horizontal till the end. And at the end you can see D is, at D we have plus P, so minus P plus P will bring it to 0. So here I will write minus P. So this is shear force diagram. Now we will draw the bending moment diagram. So for that I will draw horizontal line x in inch, and moment you have moment. Now what we will get is that we will take this will be equal to 4P, this will be equal to 8P, similarly minus 4P and minus 8P. So we know that area under the shear force diagram will give you bending moment. So first area is this one, and this area is equal to how much? This is P, this magnitude is P, and this length is 8 inch. So 8 into P is 8P, and 8P, I will write it 8P. So moment at point A is equal to 0. At point B it will be equal to 8P. So 8P is this one. And how we will join this line? We can see that this shear force is a horizontal line and this area is positive. So bending moment will be 1 degree line, straight line, and slope will be decreasing. So we will join these two lines straight. And from B to C there is no shear force. So bending moment will remain same till point C. And at point C you can see we have another area, and this area is also equal to 8 is the length and minus P is minus 8P. Clear? So plus 8P minus 8P will give you bending moment 0 at this point. And this area is negative and the shear force is a horizontal line. So bending moment will be 1 degree higher. It is a 1 degree line and slope will be decreasing. So this is our bending moment diagram. Now we know that bending moment at section B and C remains same, 8P. So what we will do is that we have this equation, sigma is equal to M into C divided by I, where M is the moment. Now what will be I and what will be the value of I? So you can see this is the cross section which is inverted T, and by using parallel axis theorem we will find I, parallel axis theorem we will find, and this parallel axis theorem is I is equal to sum of this 1 over 12 BH cube plus AD square. Now we have two members. You can see this will be 1 and this will be 2. So if I take this horizontal line as a reference line, so what we will be getting from this, so if I elaborate this formula, so it will be equal to 1 over 12 B1 H1 cube plus A1 D1 square, plus for member 2 it will be equal to 1 over 12 B2 H2 cube plus A2 D2 square. We will see in a while. Okay, for this first member, you can see that breadth is 4 and height is 0.5. So I can write it as I is equal to 1 over 12. B is 4 and height is 0.5 cube. What will be the area? So area will be 0.5 multiplied by 4. And what is distance C? Okay. Sorry, D. So D is distance from neutral axis till centroid. So first we will find the centroid of this beam, as it is not given and this is not symmetrical. So how we will find centroid? So for centroid I will write the formula is that y bar is equal to y dash bar into A divided by sum of area. So for two member it will be y1 dash bar into A1 plus y2 dash bar into A2 divided by A1 plus A2. If you take this line is reference line. So what is y1 dash into A1? So A1 is this area, 4 multiplied by 0.5. So 4 multiplied by 0.5, and y1 dash is distance from neutral x, so from this base till the mid of this section. This will be y1. This distance will be y1 dash, and this is, you can see, that is equal to 0.5 divided by 2, which is 0.25, plus what is area A2? So area A2 is this one, 0.5 multiplied by 2. So 0.5 multiplied by 2. And what is y2 dash? So y2 dash is distance from this base till the mid of this section. This is y2 dash bar. And this distance is 1. So 1 plus 0.5 is 1.5 divided by sum of area. So sum of area is 0.4. First area is 0.4 multiplied by, 4 multiplied by 0.5. 4 multiplied by 0.5. And the second area is 0.5 plus, because the sum of area, so 0.5 multiplied by this 2. Okay. When you calculate it, you will get y bar will be equal to 0.6667 inch. Now, what does it mean? It means that from this baseline, this y bar will be at a distance of 0.667. Okay. This will be somewhere here if I draw a line. So this will be y bar, which is the distance from this reference line till the axis, that is neutral axis passing through centroid. Now this is y bar. So what now we will move toward D1. So what is D1? Distance from this neutral axis till the mid of first section. So this will be your D1. If you look at this will be D1, and this D1 will be equal to y1 bar minus 0.25. So I will write it y bar is 0.6667 minus 0.25 whole square. This is the moment of inertia of first element plus 1/12. Now breadth is 0.5 and height is 2. So breadth is 0.5 and height is 2 cube plus area, which is 0.5 multiplied by 2 and d2 square. So d2 is distance from neutral axis till the mid of this section. So you can see this is neutral axis and this is the mid of the another section. Clear? So this distance will be equal to d2, and this can be obtained if you subtract 1.5. If you subtract y dash from 1.5, because this distance is 1.5. Okay, so I can write 1.5 minus 0.6667 whole square. Now when you solve this, you will get this moment of inertia will be equal to 1.41667 inch power 4. Okay, so you have now the value of m from the bending moment diagram, and I we have calculated. Now you can see that bending moment will remain same, 8p and 8p both at B and C, and this is positive moment. So what will, if I draw the section over here like this, so this is positive moment is equal to 8p. So if I take this above point is point A and below point is point B. Now we have been given that for allowable normal stress for compression is given as 18 ksi, that is minus 18, that means compressive. So what we will do is that we will find, due to this loading, you can see the upper portion point A will be in compression while point B is in tension. So what we will get is that sigma A will be equal to maximum bending moment into CA divided by I. Okay, so sigma is 18 ksi, maximum bending moment is 8p, and what is CA? CA distance from this is point A is at this point and point B is this. So distance from neutral axis till top will be CA. This distance is CA. So how we will calculate it? So 2.5 is the total distance. So 2.5 minus this distance from neutral axis is 0.6667 will give you how much? This will give you 1.833, and this distance will be CA. So I can write it, CA is equal to 1.8333 divided by I is 1.41667. So from here, when you calculate, 8p will be equal to 18 multiplied by 1.41667 divided by 1.833, and if again you divide it by 8 on both sides, so what you will get is p will be equal to 1.739 kip. This will be the value of p. This will be p, and this p is for allowable bending stress for compression. Similarly, for allowable bending stress for tension at point B will be, this will be in tension. So sigma B is equal to maximum bending moment into CB divided by I. And again, maximum bending moment is 6 ksi in tension, and maximum bending stress is 6 ksi, bending moment is 8p divided by 1.41667 is the value of I, and CB is distance from this neutral axis till the bottom, that is y bar, and y bar we have calculated is 0.6667. So 0.667, and from here we will get 6 multiplied by 1.41667 divided by 0.667 is equal to 8p, and p, when you calculate it, it will be equal to 1.594 kip. Now you have two loads, p for load. One is this one and another one is this one. So what will be the answer? So you have to choose P is equal to 1.594 kips. That will be the largest permissible load that can be bared by this beam and for the loading shown. And that was all about this problem 5.85. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.